Hello and welcome to week 2 of IS 335. Sorry about the last video. I watched the first minute of it, make sure there was no weird sound issues, and it was fine. Last semester I was having sound issues where there was crackling, and I seemed to be able to get rid of that, but now this video stopped halfway through, so at least now we have a better video. So a couple quick things to go over before we get started. Actually, let's see, what do we have in here? Yeah, we go over this. So one of the questions somebody asked me was, how do I get to the book, or how do I access the learning material besides, me speaking didactically? So let me show you how to do that. So let's log into Web Campus. Go to a course. So if you click on modules right here, again, it might look slightly different for yours, but access and register mind tap. So you click on here. We'll pause it while it loads. Okay, yours might look slightly different, but if you click over here, this is where you get, let me see if I can get it over on the screen here. If you click here, this is where you can access Office. I know that about maybe a third of the class has Macs. I have a Mac too. This is a PC I'm using now, but if you start having weird problems, or if you try to do some really advanced stuff, the Mac might not work. I don't really foresee a big problem with anything we've done so far that the Mac's going to have any problem with at all. Watch, now it proves me a liar. But in general, Macs can do everything the PCs can do for about 80% of Excel work, if not more. So if you do need it, it's here, or you can VPN onto campus. So here's a book. So you can go here. And you can go through the book. So here's a book. You see this same thing that I have on my iPad. Try to make it I just have my screen really small. That's how you actually access a book. And you can highlight, you can do, I think if I highlight it might mess up, I guess it doesn't mess up your book. Here's what Evernote. Okay, so but again, right here, full book. Table of contents, chapter 2. Good job. I want to learn about rules and frequency. Boom, it's right there. So another thing, I just closed out and I just thought about this. Another thing that might help you is the videos related to the chapters. So let me show you how to get to that and load or access the mind tap. And this week we're doing chapter 2, second week, chapter 2. So I'm going to go over here to, instead of the calendar mode, which shows when things are due, I'm just going to click right here. And actually I'm going to go to chapter 2. And this kind of lays out how chapter 2, chapter 3, everything's laid out. So I'm just going to click right here. And hopefully it looks the same on yours. You can watch this professor right here talk about, a little bit more detail than I go into, to be honest with you. You can unmute it.
Largest value and the smallest value. The variant of variation, which indicates how large the standard deviation is relative to the.
So you have that, and you, like I said, you can go through in here and see more stuff. There's more videos. Hey, I don't know what correlation coefficient is. So there's videos, there's interactions, there's a ton of stuff with this book. So I know it's just a lot, but I just want to kind of show you that because I know students were a little confused. So that was one. Oh, number 2, yeah. So I'm just trying to go over some of the questions. You can set up a Zoom meeting. So you go through and you have a question, you Google it, you chat GPT'd it, you can't figure it out. This doesn't make sense because just today I was talking to somebody about left skewedness and right skewedness on a distribution, but they learned it was positively skewed or negatively skewed, just a different term. So you get confused, just shoot me an email. We'll set up some time to do a Zoom meeting. I mean, I meet all my students, so we'll just set up a Zoom meeting. Generally, Thursday, Friday, Saturday, and Sundays are better for me. The later in the week are better. I know Monday's a holiday, but if you guys want to meet up on Monday, just let me know. I can set up a Zoom meeting, and we can go over any concepts, Excel questions you have, or anything else like that. So don't be afraid to reach out, because I'm here to help. So what do we have here? Heat looking up so high. So 1 second. Okay, let's go over this. So somewhere along the line, somebody told me, again, this is kind of what's expected of you this week. Some things are less important. We'll go over the power. When we go to my iPad, we'll go over it a little bit more in detail. Okay, but things like z-score are important, quartiles are range, standard deviation, mean, mode, median. Those are all very, very important. So we'll go over that. So remember, MindTap, what I just showed you, at the bare minimum, do the assignments. Those are always listed in Canvas under assignments. So they're always listed there. Number two, the discussion, find a lie. So all I'm looking for in this is just look at media or look at blogs or websites where they use information that might not be 100% accurate, or they misled the truth. And you'd be surprised how easy it is to find. I found one today. So, I mean, just literally on TikTok, they're out there. On everything and anything, they're out there. So they're not hard to find once you start looking for them. The research idea, just start getting an idea. Again, I'm not necessarily worried about the research idea. I'm more worried about how you present it. And the best analogy I can give you is, I don't really care what type of vehicle you drive. I care how you drive it. If you drive unsafe, then it's not good for me. It's not good for any of the other students. It's not good for anybody. Okay. Same thing with the research idea. I want you to present your idea in an effective, safe manner that you can do it. That your boss will be like, oh yeah, this is a great idea. I want you to pursue this. Okay. And there's a syllabus quiz. Maybe some of you did it already. Maybe some of you didn't. It's super easy. Take it as many times as you can. Basically, just ask, hey, did you read the syllabus? Do you understand the AI policy? Things like that. So now, why stats? When this video had problems, I called IT and I called Cengage, and I was talking to one of the people on the phone, and I told him, when biology started, or at least let's say for the last 150, 200 years, biology was really a soft science. Biology, they'd find a bird and like, well, it looks like this bird, a toucan and parrot. They kind of had to take a guess, an educated guess, which is really what statistics is, but they had to take guesses about where this bird would fit in this taxonomy, where this bird is, what it's related to. Well, somewhere around the late 90s, biology moved from, I would say, a soft science to hard science. Now everything in biology is all computers. It's all, hey, genetics. It's, now we can exactly identify where the species fits in. And it's not only that, it is now everything that we do in business is the same way. We don't want to take second guesses. One of the guys I work with at the university, he got out of industry. So he went through and got his PhD, went out and went into industry, and he found out, and this was probably 8-9 years ago after he graduated, that he did marketing, that he could show quantitatively where it was best to spend marketing money, where the biggest impacts would be, and things like that. But the company he worked for didn't want to listen to him. They just wanted to spend money. They had a gut feeling it was good to go to, hey, let's do this, let's do that. And he said, hey, it's not a good idea. We're not maximizing our income. So he worked there for a couple of years and left. Well, they're not doing as well as they could have because bad marketing. So literally, data isn't everything. Last week I talked about how a history major, and I mean, think about it, history major, my grandfather was a history major, and I don't know, I'm not a history major. Maybe you read about American history, you read this. How can that be data driven? But it is. So much of history is data driven. We have an esthetician in the class. Esthetician now is all data driven. Everything we do, no matter almost how esoteric, is all data driven. So if we can understand data better, we have a leg up better than everyone else, which means we'll make more money than everyone else. So if we can understand the data, then we can get the good information to the right people at the right time. That's a really big thing in medicine, getting the right information to the right provider at the right time. Okay, and that's where a lot of statistics comes in. You don't want to get wrong information at the right time. You don't want to get the right information at the wrong time. So, and stats is here to help. It helps us do repeatability. It helps us be valid, have validity. So, before we get into stats or into this chapter, I do want to talk about cognitive biases. And normally I have a discussion where we're talking about cognitive biases. I don't think I have one this semester. But cognitive bias, again, I do neuroscience, so I study the brain, and it's a really big issue. And these permeate through business, through data, through collection of data and everything else. So by just being aware of these cognitive biases can potentially help us mitigate them, or at least make us aware of them. If we think everything is perfect and it's not, we can have problems. So anchoring bias, for example, and I'm not going to read all of these, but anchoring bias is the idea that, hey, we kind of remember the first piece of data, or we remember the first thing. So if we're in a class of, I think there's 60 students in this class, we're most likely to remember the first 2 or 3 students' names and the last 2 or 3 students' names. That's basically anchoring bias, those first 2 or 3 students' names. And this goes on to a lot of things. We look at a news story, we remember that. We go in a grocery store, and we kind of remember the first couple things we see. Okay, confirmation bias is the analogy we always use is, hey, if you like Fords a lot and you think Chevys are a horrible vehicle, you love Fords, and you just think Chevys are bad, you're driving down the highway, oh, look, a Chevy broke down. Oh, look, another Chevy broke down. Well, I don't see any Fords breaking down. You're confirming your own bias. Okay? And there's a lot of other ones. There's a great little chart about different cognitive biases. But, as we go through college, as we go through life, it's important for us as adults, as data people, to understand that we have cognitive biases in data and Excel and everything that we do. And stats kind of helps us maybe mitigate these if we can. So let's move to Excel. So why Excel, Richard? Why is Excel so important? I'll give you a couple real quick ideas on Excel. So Excel is almost on every computer. I mean, you can go through UNLV, and if it's a Windows or Mac, it probably has Excel on it. There's not many other programs that are that spread out. I mean, literally, Excel's on everywhere. Excel now can do a lot. I mean, it sums, averages, but more than that, it takes data, it takes a spreadsheet, it takes information in some type of structured format and gives us results. It either allows us to confirm what we know or what we don't know. Going on to this little graph over here, something I saw on, I think it was LinkedIn. So this is from last year, November of last year. 1,400 job postings. Look at that. Excel was the #1 thing they request, and SQL is #2. So Excel is so important for being a data analyst. It is so important. Like I said, I try to explain that I don't use Excel as much as I'd like to at my work. Today I was working on a project that had 22 billion rows on it. Okay, and I mean, there's just no way that I can put even 1/10 of that into Excel. So sometimes I work on very big data projects where it's not feasible. However, there are other times where I take the data and I find the results of the data and I pipe it into Excel. So I'll say, hey, out of these 22 billion rows, 18% of them did this, 23% did that. I would totally put that in Excel. So Excel, I mean, is used by a lot of people, not only in data analytics, but in human resources, in frontline providers, in fire engines and fire stations. It's used all over the place because, again, it's so common. Number 2, there's a lot of videos on Excel. You can go to LinkedIn Learning. There's a ton of stuff on YouTube. There's training everywhere. Okay. And number 3, Excel allows you to call somebody's bluff or not call somebody's bluff. Okay. Is the average temperature getting hotter? Well, no, it's not. It's a global warming, it's a conspiracy. Well, Excel in 15 minutes, we can at least get some ballpark numbers. You know, I mean, it's that simple. A lot of times when people try to tell you things or say things, you can start digging in really quick. A college education is not worth, well, we can dig in and find out if what you're saying is BS or if it's true. So that's one thing I love about Excel. What else did I cover here? Data analytics. Another thing is Excel can do visualizations really, really quick, which is nice. You know, Tableau is probably better. Power BI is probably better at doing visualization, but Tableau is really quick. And, you know, I showed you that iron triangle, quick, fast, or good. Tableau is quick and fast, and that means a lot. I mean, do you really want to spend 3 days doing a visualization on something where you can do it in Excel in 2 minutes? It might not be as great, but again, it gets a point across, you know. Collaborations, you know, again, Excel, you can share worksheets with people, either online automatically, you can email it. There's a lot of collaboration where in Python, we all have to have the same version of Python generally. We have to have all the same modules. It becomes much harder, okay? Widely used, trusted financial modeling, blah, blah. Let's see what else we have. So how to get better at Excel. And again, I try to explain to this as best I can. Literally, to get better at Excel, it's shortcuts, which I'm not really going to go a ton into in this class, but which I will do in this class, a lot of work, just doing it over and over and over again. It's muscle memory. And so if you ask me, one of the things that really college kind of prepares you for, it's doing things that you maybe not necessarily want to do and doing them again and again and again. Because I know that you can go to YouTube and learn how to do something, but that may not be what's asked of you in the business world. So for example, if I give you a homework assignment, well, it might not follow the book, it might not follow something you find on YouTube. You're going to have to find a solution for yourself. You're going to have to find a way to say, hey, this is the goal, how do I get there? And it's those challenges that, in a large part, at least in my mind, that college prepares you for. It helps you find solutions and practice that you might not have done on yourself. Okay, and I know that sounds weird, but it really is. So I was okay with Python before I went to college. I wasn't very good. I mean, just barely hacked my way through it. But you know, through 3 or 4 years of taking Python classes and learning and doing things I didn't want to do and figuring out, hey, this is crazy. I know there's better ways to do it. Through doing all that, I got much better at Python. I got much better at Tableau. You know, because what happens is when you do something in Excel, then I'm like, well, what about this? You know, I don't know, let me try to figure it out. And you spend a day or two figuring it out. Next time somebody else asks you that, it becomes a lot easier. So another thing too that Excel is data validation, error checking. So it doesn't matter if you graph or you somehow find a way to validate your data. It is super important. I think that's one of the big problems that people have is they don't validate their data. Not just college students in general. I mean, I'm guilty of it. Everyone's guilty of it. And it's hard sometimes to validate your data because you don't know what's good data and what's bad data, you know? So just keep that in mind. What else do we have? So warning, so Excel, I have an Excel document on my desktop, or it's a CSV, and it's 15 million rows, and I know I can't work on it in Excel, and it'd be great if I could, because I'm looking for some data that'd be super easy to do in Excel, and I can't do it. So Excel is capped about 1 million rows. So Excel also does auto formatting data type. So what does that mean? That means if it sees something that it thinks is a date, it's going to try to make it a date. And this is a problem with genes and things that might have non-standard names. So you might name a person Alice, and you might name a person Todd, and you might name a person 9 September. I mean, if you look at TikTok, there's all those teachers on first day with funny names, you know, and again, there's some weird names, you know, to Shay, you know, I mean, things like that. Well, Excel might see that and think it's an actual month and try to convert it. Well, with genes, genetic genes, like biology, this was a big problem. More than 10,000 papers with Excel gene names published found 30%, so 3,000 contain at least one gene name mangled or changed or perturbed by autocorrect. That's horrible. That's 3,000 papers. That's countless hundreds of thousands of hours of labor just messed up by Excel. So just remember that sometimes Excel does this. It tries to auto data type. Excel doesn't always work really well when you're managing relationships. And I mean, like, hey, you have one Excel document and it links to another Excel document and it links to another one. Sometimes those don't always work really well. You know, that's something that SQL is very good at, in tracking changes. In terms of like legal obligations, sometimes you might have to do audit obligations. So before I go into this, I want to kind of go over the book. I think that's kind of the best thing to do now. So give me 1 second. Let me get the book out, and then we'll go over. Actually, let's go through a couple of these. Actually, let's go to the book. See, indecision. Okay, so this is just kind of what I think are the most important things that you'll need to know for the rest of your life. Not just this class. Hopefully you've taken a statistics class, but it doesn't really matter. The things highlighted are the ones that you're going to need to know in probably relative frequency. I just saw it today on something I was working at work. These are the ones that are going to be fundamental, important. Range is kind of important, but that's pretty easy to understand. These are going to be the ones that are going to stick with you the rest of your life. So let's go through a couple of them in the book here. Okay, so sample and population. We have to understand that most of the time, not all the time, we can't get a whole population. And what do I mean by that? So, move this over here. So if I want to know the average height of a UNLV student, would it be feasible for me, even if I had $100,000 or $500,000, to force everyone at UNLV to stand in line and measure themselves? Nah, I couldn't do that. So what I'd have to do is take a sample. I'd have to say, hey, maybe on Monday morning, I'm going to measure 100 students, or I'm going to measure 500 students. Okay, so you're taking a sample from a population. And 99% of research is this idea that, hey, we're taking a sample and we're taking it of a population, then we're trying to infer that back to the population. So moving on, there's two kind of types of data. They talk about categorical, but I really want you to understand that there's quantitative data and qualitative data. Okay, so quantitative is a number. Okay, so your GPA 3.2. That's quantitative. How you feel about the class? I'm happy about this class. Richard's a great teacher. Make a little smiley face. Okay, that's qualitative. Now, a lot of the new data analytics, a lot of the new world, we're looking at qualitative data, not quantitative, qualitative. For example, one of the projects one of my coworkers was working on today was, does an agent on the phone, hi, blah, 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 do they make a promise to do some type of action? Okay, so go to Reddit and look at UNLV and look at how many people are like, oh, financial aid never calls us back, or, this financial aid never called me back. Those aren't quantitative numbers. Those aren't quantitative problems. Those are qualitative problems. So what if I could take every call and say, hey, look, you've had 1,000 calls to financial aid. 500 people made, 500 UNLV staff members made promises to call these students back, and only 30 did. Would that be helpful? Yeah, the president could be like, oh, look, we need to make an initiative that if you make a promise, you have to make a call. You have to follow up with that promise. Whereas if I looked at qualitative data and said, hey, we had 1,000 calls, blah, 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 500 promises were made, 490 people called them back, well, it's not a big deal. 10 people missed it. Maybe they went on vacation. So qualitative data is becoming more and more value driven. Okay, it becomes more important. And the book doesn't really talk about it because, again, you can't do statistics on it. But I really want you to understand that there's kind of those two big buckets of data. Now, categorical data, that's things that we throw in buckets. Okay, if you look at the Olympics, first place is a categorical variable. Second place is a categorical variable. So we look at the categorical variable, so all the first place medals. Well, we know that runners got X amount of time. Maybe the average runner did it in 3.3 seconds. And the swimmers did it in 15.9 seconds. Okay? So those are, that's the categorical variables are first place, second place, third place. Okay. Um, it is a way of putting things in buckets. We're going to go in time series in, I think, chapter 9. Time series is super important, but I think it's just a little early to jump into it right now. So let's see. What else do I really want to hammer in? But like I said, these are things you're going to need to know all your time. Sorting and filtering in Excel. Make sure you know how to do this because that's like 90% of the work that we probably do in the world. I don't know what I talked about there before, so let's keep going. Okay, so now I wanted to hit on this one here. So relative frequency and percent frequency. Most of the time you'll see percent frequency. That is something that's relatively common, okay? Is there another graph here? So all we're saying is that whatever category these are in, this is how often it happens. We're doing the same thing with relative frequency. But percent is just easier for us to digest. Okay, so in theory, in an A, 10% of the class gets it. B, 10% of the class gets it. This is your categorical variable, and this is your percent frequency. In my class and most other classes, that's not truly what happens. Percent. Sorry about my writing. I know I write horrible. But again, it is just, the way it is. So I just read yesterday that 1/3 of accidents in Vegas are speed related. Or sorry, 1/3 of deaths, I think, are speed related. So the category is the reason for death is speed. So I mean, it's the same thing. So most of the time you'll see percent frequency. And all they're talking about is, hey, out of all these categories, this is how often you'll see this one occur. Number of bins, another great little distribution down here. And there's some programs automatically make bins. There's a couple of formulas where you can figure out the appropriate number of bins. But I just kind of want you to keep in mind that the number of bins, so bins are these right here. Okay, it can determine how something looks. Okay, so if I look at this, it looks kind of just like a U shape here. Now look at this one with 2 or 3 more bins. Whoa, what happened? If I live to this age, do I live longer? It's kind of, so that to me, that's kind of misleading. When I do 10 bins, this looks better. Okay, so just keep in mind that the number of bins can affect a lot of things. It can affect how, I don't want to say how accurate the data is, because that's not really accurate. It can affect how we perceive the data. It can have a lot of impact. So I made a note on this before. So remember that left skewed. Okay, so how our data looks. Why is this important? If I was to give you data, it's hard for us as humans to imagine that data. It's hard for us to visualize that data. Okay, and so one way we do that is by looking at, kurtosis, skewedness. Is it a standard distribution? Things like this, and that can help us say this data is like other data, or it's not. Okay, but one thing that's always weird is if something's skewed left, that means that it's missing basically the left side. And again, I had all types of problems with this when I was in college. And somehow you just kind of got to force yourself to learn it, okay? So I know that I missed questions before they were online. They were like, I know, Scantrons, it sucked. So now if it's skewed right, okay, it's kind of missing the right-hand side. Yeah, if it's skewed right, it's technically heavier on the left. Weird. And so there's another term, positively and negatively skewed. Okay, we're not going to cover that right now, but if you want, I can go over that. Symmetric just means it's a normal distribution. Okay, so just normal bell curve. What else do we have here that I thought was important that you need to know for the rest of your life? So there's mean. Mean is basically just the average. And I'm thinking about putting down a data set real quick and showing you. Now, mean is or can be affected a lot by outliers. So what do I mean by that? So if where's that skew? So if you well, if I was to take the mean here, okay, boom, would be here somewhere. But now, if this thing kept going and kept going and kept going and kept going, and I had something that was really, really far out here, okay, then my average would be all messed up. So that's really, that is the one thing that you always got to keep in mind with averages, okay, or means, is that they're really affected by outliers, okay. So, like I said before, I'm not worried about you learning the math formula right now. Excel, you put numbers in, you hit give me an average, it gives you an average. If you're really interested in writing some program or doing Python, and even in Python, it says, hey, just give me an average. Everything just does average. You don't need to do the formula. Maybe if you decide to get a statistics degree, you'll have to know the average. You have to know the formulas. But for this class, I don't expect you to know any formulas. This is not a math class. This is a business class. At least the way I'm going to teach it's a business class. So the important part is the goal. Okay. Now it's important you know that what the average is and how outliers can affect it. Okay. But those are important parts. For example, I average this. I don't know. Let's say I get 300,000, whatever. But this one, it was 5 million. This would dramatically change. Okay, let's say it moves up to 8 million. Even though the bulk of my numbers have not changed, only one of my numbers has changed, it has a dramatic effect on the average. So to fix that, we use median. Median is just literally the middle number. If you sort everything from high to low, where is the middle number? If there's two numbers, you take them and cut them in half. So median is not necessarily a better understanding of the middle of the curve, but the median allows me to understand, hey, if the average and the median aren't similar to each other, there's a problem. So if I look at the average house price in Vegas and it comes out to 700,000, which we just go do right now, and the median price is 500,000. Okay, and I'm like, maybe there's a lot of really expensive houses here that's driving this up. If I do the same thing for, let's say, I don't know, Arizona or somewhere, let's try to think of state, Maine, I don't know. Think of Rhode Island. Okay, if I do the same thing for Rhode Island and the average is 600,000, and the median is 590,000. I know that in my head that there's not a lot of outliers in that data. If that makes sense. Mode is the most common value that occurs in your data set, or at least whatever you're trying to calculate. Sometimes it can be used, you're looking at marketing terms and maybe you want to use a mode to work on that. We use it for, say, hey, this is the most common number. I mean, that's literally what you use it for. So the range gives you like the start to finish. Okay. So, I mean, if you, let's say the teacher, or let's even do a job. Let's say you had a job and the range of salaries was, I don't know, 50K to, I don't know, 55K versus another job which was 40K to 160K. What one would you take? It tells you, hey, this one, for the same job, they're hiring people a little bit lower, but a lot higher. This one's a little bit tighter, it's the range is more compressed, or there's less variance. For some things, that's really good. For some things, that's really bad. If you're looking at how often vehicles break down, you want a very predictable vehicle. Okay. So here, like this. Variance is a measure of variability that utilizes all the data. So variance is a deviation about the mean. Okay, so I guess that's, again, we don't need to know the formula. But variance is, let's see if we got a good picture of variance. We don't. So here's kind of your variance, okay? So if the average is 1,000 here, I can go through and look at kind of where these are away from 1,000, and that's kind of my variance. Standard deviation is kind of the same thing. Where's standard deviation? Standard deviation is basically a square root around that. We do the square root so we can basically get rid of positives and negatives. That's, square root's really important because square root tells us how far most of the data is, how far some of the data is away from the center point. Okay, that works. Percentiles, we use these. We use quarters generally more, but if you say, hey, I'm graduating in the top, I graduated Magma. Magma is, I think, top 5% of the class. So that tells you that when I studied psychology, I was in the top 5%. It doesn't really matter, but why is it important? Because if you compare psychology to like history, the top 5% of psychology might have more students because it's a larger college as compared to history. So we use percentiles to kind of break down things that are variable. The top 5%, the top 1% of income earners in 2024, okay, might have to make above 300,000. Where the top 1% of income earners 20 years ago might have to make, I don't know, above 200,000. Okay, it gives us a way to compare apples to apples. Some ways to think about it. Quartiles, basically the same thing. I know I want to get, okay, so the z-score, yep, ChatGPT. So z-scores are super important, at least in business they are and in research. So you might ask, and one of the common questions is z-scores. Okay, so Richard, what is a z-score? So let me show you a good prompt versus kind of a bad prompt in ChatGPT. Maybe this will help you. If you still have questions, I'll help you, but let's just go into that. Let's see, ChatGPT. Yep, of course my Google Drive doesn't work. Okay, so bad prompt would be like, what is z-score? So that's not really, you got to remember too that large language model, if it doesn't know what you're going to ask, it's just going to start throwing things at you, and that's not really the best way to work with ChatGPT or other tools, okay? I mean, look at this. This is, we gave you a formula. I don't need any of this stuff. So let me type a little bit longer prompt out, and then we'll talk about it. Okay, so this is kind of, and this is not a great prompt. I mean, there's, and Claude and other things will help you with prompts. This is just ChatGPT, but help me understand z-scores. I don't want a formula, if I can spell right. That ChatGPT doesn't really matter. And I don't need a math understanding. Okay, so that gives you a little bit of context of what you want. I want to know why z-scores are important. Please explain it to me like I'm in middle school. Now, ChatGPT is really good at shifting feedback or levels from like elementary school, middle school, high school, collegiate level, things like this. So generally when I ask ChatGPT, I ask it to explain to me at a certain level. Maybe I'm working on some research paper and I want it at a PhD level. Maybe I'm trying to learn a new topic and I want it at a middle school level. Okay. I also want an example. Now when I ask it for an example, I want on something I'm interested in. Now, I don't know anything about live concerts. I can't even tell you the last time I went to a live concert. However, I know somebody in the discussion post was like, hey, I've been to 60 concerts, I think last year, or some number. That's crazy. I can't imagine that. But hey, that's, that's something a person's interested in. You do cars. You could do, classes. Whatever you're interested in, have ChatGPT relate it back to that. It will help you learn. So imagine you're in middle school and you're going to, and you love going to live concerts. You and your friends decide to see how many concerts everyone went to over the summer. Matter of fact, this is like very similar to what somebody posted. Okay, so me, I went to 10 concerts. My friend A went to 5, friend B went to 7, friend C went to 15, friend D went to 2. Okay, finding out what's normal. So we, basically do an average, and then we compare how, what is outside the average. Okay. So using a z-score will help you not only understand that your experience going to 10 concerts, but how your experience compared to others. Are you a super fan? Or are you like more like me that doesn't ever go to concerts? That's kind of what z-score is. Z-score gives you a standardized way of comparing point estimate of comparing numbers using basically standard deviation. So that's a little better way to use Chat GPT than just explain X, Y, Z. That's not really going to get you to the goal. I want you to really, if you're going to use Chat GPT, I want you to use it effectively, which I know sounds weird. Let's go back to iPad. Empirical rule is just saying that, hey, things have a bell-shaped distribution. So that is important because we expect things to have a normal distribution. We'll talk about distributions down the road because not everything has distribution. Life expectancy doesn't have a normal distribution, for example. Weight does, height does. You know, and it's important because when we start doing math on these things, we start interrogating these things that don't have normal distributions, we have to approach differently. Okay. Because again, we know that 68% of the values fall within one standard deviation of here. Okay, okay. We know that 95% of the values fall within two standard deviations. Okay, so if I want to know the height of 95% of the students, boom, two standard deviations, the bell curve. Now, however, if my bell curve looked like this, it's hard to do that same type of calculation. There's other models we can use for that. Now, identifying outliers. I probably should have spent more time on this before, but when we found an outlier, and I think I used a reference that when I was working here in a clinic, I found 2 or 3 patients that had weighed above 40,000 pounds. It's 40,000 pounds. Now, I know that these patients did not weigh above 40,000 pounds. They would go right through the building. I know that MRI, I was looking at MRIs. The MRI machine wouldn't hold them. They wouldn't fit in the MRI. It was a typo, okay? So, things like that are a little easier. Let's see, let's make that a little bit bigger here. A little easier to understand, or a little easier to find those outliers. But sometimes outliers aren't as obvious. I went to, you know what it was? In my lab, we had the MBA, some MBA thing. And I'm 6'3". I'm 6'3" to 6'4", so I'm pretty tall. And during that MBA, and I don't think I'm necessarily an outlier. I might be on the very edge of it. I mean, we can look. But during that MBA jam, or whatever that we had during the summer, everyone was like over 7 feet tall. I was the smallest person walking around that building. I mean, literally, everyone was 7 feet, 7'1", 6'8". It was unreal. I was the shortest person out of like 30 or 40 people. Everyone there was an outlier compared to the population. Okay? So now, if I was going to look at these basketball players compared to the population, they would all be disregarded because they're outliers. If I was to look at the basketball players and look at their sample and just worry about them, I might be an outlier. I might be too short. Okay? So this is important because we have to find a way to identify the outliers so we can say, hey, we want to remove them, or we know about them. And if we remove them, we just have to document them, why we're removing them, and how we figured out they're an outlier. Okay? Now, I have a note on this about box plots. So with box plots, it would be so nice if everything just worked like this. Oh, my picture didn't show back up. There we go. So with box plots, it would be nice if everyone did them the same. But I've hit programs where they don't calculate these box plots the same. So it's kind of outside the scope of this course about what programs do, what programs don't, and how you create box plots. There's a Medium article that shows violin plots, a few other things. But just remember that not everything works this way in terms of box plots. Most of the time they do, but not all the time. Okay. Let's see what else we have here. So let's just go through the slides. Oh, nope, there's one more thing here. Correlation coefficient. So what this does, this tells us how close X and Y are related. Sometimes for some things we want them to be very, very related. Sometimes we don't want them to be related at all. So when we cover linear regression, things that are very closely related, we want to get rid of. We assume that all our variables are independent of each other. Okay, but for some things we expect to have a high correlation coefficient. Okay, so let's do education level and the good old-fashioned income. We know that both things are related. I can Google it right now, find 10 charts and papers that say, hey, the more education you have, the more income you have over your life. Those things are positively correlated. Now, there are other things that are negatively correlated. And that's not a bad thing, because remember, negative is just a direction in this term. So if we look at education, again, sorry about my writing, education and the chance or the percentage of people that die under 50. Those are negatively correlated, meaning that as you get more education, you're less likely to die under 50. And then I think there's a graph in here. Oh, where's... Okay, here. So positive, approximately 0, and negative. Okay. So remember that positive, negative, and I go into this in my PowerPoint, so maybe we'll switch over right now. These are, just because something's positively correlated does not mean it's a good thing. It doesn't mean it's a bad thing. It just shows there's a relationship between two variables. And that is so important. I cannot express that enough, okay? That if we're looking at X and Y, it really depends on what X and Y are, okay? We look at education and income, we want those things to be related. We don't want, drunk driving and chance of death, percentage of death. They're also very positively correlated. The more you drink and drive, the more likely you are to die, the more likely you are to get a ticket. Speeding and the number of tickets, very positively correlated. Okay, so let's switch back over to the PowerPoint, and let's go through that really quick. So I'm not sure, like I said, the best way to kind of help you get through this material, because, when I had to learn, I had to sit in a class, and the teacher would literally just write on the dry erase board, and it was horrible. So range I talk about is just the top number to the bottom number, and sometimes that's important. The range of students in a class. I'll give you a great example of this. When I think my second class, you would assume that's 18 years old to, I think it was like 38. However, we had a 17-year-old in that class, and that caused a lot of problems because he couldn't consent because he wasn't 18 years old. Okay, so knowing the range of something is very, very important. If I know that ranges of houses in Southern Nevada, let's say ranges go from 200,000 to 200 million, I know that there might be a problem on one end. But range is just the smallest number to the biggest number. You should know that. Variance, we talk about standard deviation. IQR, again, that's just your quartiles, or your quarters. Z-score, we talked about that. Great, I don't know why I didn't think about that. Categorical variables, okay? Blood type. Type A, type B, type AB. Those are categorical variables. They fit into something. Another term that I didn't cover is continuous or discrete, okay? A continuous variable is simply a number that can have a continuous amount of numbers, okay? So, if I talk about speed, I know it's just speed of a vehicle is just limited to my ability to measure it, okay? So if I can measure a car, have a little radar gun and go boom and get you, I know you're doing 58.9 miles per hour. If I get, next year, some company comes out with a better speedometer, better radar gun, I measure you, guess what, you're doing 58.92. I could keep going on and on and on. That's, each year they come out with better measurements. Now, discrete is a number that kind of fits into something. So this is a weird analogy. There's a couple of ones I can think of, but a year is a discrete measurement. It's either 2024 or it's not. Okay, it fits in there. It's a discrete number. Blood pressure, in theory, a blood pressure of 140. There is no 140 and a half. There's not 140 and 3/4. It's a discrete number. Okay. What else do we have here? Descriptive stat. We went over all this stuff. Missing data. You know, as I talked about outliers. What do we do with outliers? And you know, for me, maybe it's just I'm a professional. When I'm doing an analysis, I say, hey, these are the outliers. I identify these outliers by, hey, you know, I did IQ, I did quarters, I did percentiles, whatever I did. I identified these outliers, and I got rid of them to ensure that the average was a better average, to ensure that everything looked nicer. Okay, to ensure that my data was more accurate. I just think somebody typed the wrong number, and so I got rid of it. When I have missing data, I have to figure out, do I want to maybe average the missing data? Do I want to do imputation on it? There's a bunch of different methods to do that. It's more common in genetics, but how do I want to deal with missing data? Do I want to get rid of the whole row? You know, so we talked about percent frequency distribution. That's a more common one out of these two. Relative frequency distribution, same thing. It just adds up to 1. Histogram, we went over this. Again, I want to really stress this. Positive linear association. Positive doesn't mean good. Negative doesn't mean bad. It shows a direction. Okay, that's all. I think that one might be from your book. Actually, your book's in blue, so it doesn't matter. Correlation plots. What else do we have? You see the average of this will be greatly affected by the 5 million. The average, this one will be a much nicer average. So, you know, if I was working on this data set and, you know, somebody either made, you know, and I saw this, you know, hey, you know, 5 million, I know that my standard deviation would be all over the place. I would say, hey, I have something wrong with my data. I want to get rid of this. So, if you have questions, let me know. You know, if you want to watch the videos in the book, go ahead. I have included, let me go back to here, Web Campus. I just included in another Excel how to do descriptive stats. And literally, so it tells you how to do it. But what's important for me, or what's important in life, generally I think probably for you, is when it spits out these numbers right here. I don't know if I can make it any bigger. Do you know what these numbers mean? What's the mean? What's the median? Kurtosis, what's the range? What's a minimum maximum? You know, what's a sum? What's a count? So for me, for you to understand that, like the sum of age, useless. Absolutely useless number. I take everyone's age and add it together. What's that going to tell me? Nothing of value. Okay, that there's 1.3. It's useless. I can tell you that if this is an age column, I don't remember what this one was. The average age of people are 40. If I take the high and low, the median is 38. Pretty close. Maybe a couple older people in this data set. Standard deviation is 10, so that I know that 68% of people fall between 30 and 50 years old. So once I can start seeing this, and I know what I'm looking at, I can visualize it in my head, and that's what I want from you, because this will help you no matter what you do. Okay? So there you go. Let me just log in here to Web Campus as I was doing here. Boom, boom. Week 2. Again, I'm sorry, I don't know what happened. I guess around 15 minutes or 20 minutes in the video, it freezes. Technology. We all have problems. I call it OIT. I call it Engage. Actually, I should try to do that. So if you need help with additional stats stuff, this is a great channel, Stats Quest. Super great. I mean, I love Stats Quest. Their stuff's not super heavy. They're direct on it. So you can always watch their stuff and say, hey, I want to know about ridge regression. Boom, you can go there. I think this is the same method on the video that I just showed you, how they did it. And then here, this, I don't care about the Python. You don't have to know the Python. Nobody cares about that right now. Let's just talk about some of the things. So here again, is that box plot? Okay, but the violin plot. I wanted you to kind of see a violin plot because they're very useful. They're more common nowadays. But a violin plot, I guess these kind of look like a violin. It kind of shows you the breakdown. Instead of just having a box, it shows you the difference. So, what else does this thing show that I really liked? Okay. So just different types of graphs. And I think you do all these in Excel. There's other programs that can do this. So okay, that's that. We'll cover heat maps later. That's a horrible example of a heat map. Correlation plot. Hey, how large is year built to sales price? So that's kind of what it shows us. So let me go back here. Oh, close. So again, the research project, I have a couple videos on. I'll make another video because I just kind of want to make, I don't want to stress you guys out. I just want to make it very easy. The research project, not something you should stress about. A couple pages. There's a draft that's due. I'll give you feedback, but just tell me why you want to research it, how you plan to research it, kind of how you plan to present it. Sign up for collabs. You can use your UNLV Gmail account. I don't know if we're going to use this, but if we do, we'll use it for SQL towards later semester. It's just one less problem we have to do. SAS channel, this, that. Here's this video. It's very similar to that one up there. This is, again, the PPTs from the actual publisher, if it helps. Let me know if you have any questions, and we're right at the hour. Good luck. Let me know if you have any questions. Thank you.